Hello everyone, my name is Nilesh. In this video tutorial, I'm going to talk about Apache Maven. You might be knowing that Apache Maven and Gradle, these are two most popular Java build tools. In this video, I'll tell you what exactly Maven does. We will also understand what are Maven repositories like central repository and local repository. I will tell you when you create a Maven project, what exactly are the contents in pom.xml file and how that pom.xml file is processed. We will understand how Maven build your project because it is a build life cycle. And finally, I will show you how to do a Maven project in Eclipse IDE. So I guess you are excited for this. Let's get started with this. The first, I want to tell you what exactly Maven does. If you are writing a very simple Java application, you can just create a simple Java project in Eclipse IDE and start using it. By the time you are using built-in Java libraries like collections and threads or sockets, it is always easy to do that. But when I talk about the enterprise level applications, now for the enterprise level applications, there is a huge code and moreover, it is using lot of third party libraries. The libraries for the JSON conversion, libraries for the database connections, libraries for the connection pooling mechanism, libraries for third party framework like Spring, Struts or something else. Now, if you are using all these libraries, you need to manually start adding all those library jar files in your project class path and then you need to build it. Many times these libraries themselves are dependent on some other libraries and you need to be careful while downloading those libraries as well and that too with the right version. And trust me, for the huge enterprise application, this could be really tedious task. This is where the build tools like Maven and Gradle help you. The very first thing that Maven does for you is it downloads all dependencies directly from the Maven central repository on your machine into your local repository. Of course, the primary job of a build tool is to compile the source code and create .class files. Definitely Maven does that. Followed by that, it will also create a package, maybe a jar file or war file depending on your application requirement so that it is ready for deployment. And you can also share this packaged jar or war file for other projects on your system or your colleagues. You can do that. As I have talked about, like Maven, central repository and local repository, you must be interested in knowing what exactly it is. Okay, this diagram should help you to get the clarity what is Maven central repository and Maven local repository. Here you find that Maven central repository is available on internet. You can go to the mvnrepository.com. That is a central repository. All frameworks, third party popular jars, they are shared, published on this Maven central repository. But you cannot add them into your project class path directly from internet, isn't it? So Maven take care of downloading them from the central repository to your machine, your local repository. Now, where exactly your local repository is? The local repository of the Maven is a .m2 directory in your home directory. If you are on Linux sort of environment, then it should be under /home /username /m2. Please note that the name starts with dot, so it is a hidden folder in Linux. If you want to see that, you might need to enable the hidden folders under Linux Explorer. As far as Windows is concerned, it gets stored under the profile directory, and in the profile directory is like c:users slash your username slash dot m2. Now that is a place where all the jars will get downloaded from the central repository into the local repository. However, if you are working in some enterprise application, you are working in some organization, they may not be interested in publishing their libraries, which are proprietary one, on internet. They want to keep it limited to their organization. Now at this time, instead of publishing these libraries on central repository, usually companies create their own remote repository, which typically is kept into the organization internal network. Of course, you can download your own company specific jars, your own project specific jars from there into your local repository. By default, Maven will always download it from the central repository. If you want to get them downloaded from the remote repository somewhere into the project settings into pom.xml, you need to mention the path of remote repositories as well. Now, as you have got a bit more idea about what Maven repositories are, now it's time to talk about the heart of Maven, that is Maven pom.xml file. The Maven pom.xml file is a place where you want to put all the build settings applicable for your project. Now, what exactly it contains? Yes, it is quite complicated. It has got so many things, but I will try to limit myself to some very basics that must be known to every beginner. The most important thing as a beginner that you see is nothing but the dependencies section of the pom.xml. By the way, POM stands for Project Object Model, and it is a XML format which has to be written in some specific syntax. As whatever third-party jar libraries that we are using, those libraries has to be mentioned in a proper XML format. You call it the dependency. Now, each dependency have at least four important tags, subtags. One is a group ID, which indicates that this particular library, this particular jar is being developed by which organization. Then there is something called an artifact ID, which tells you about the name of that library, name of the particular jar. Third one is version of the particular library, and fourth one is nothing but scope. Now the default scope is compiled, meaning by these jars has to be downloaded and added in project class path, and they are required for compilation of the project. However, this is not the only scope that we have. There is yet another scope. We call it as a provided scope. Now, what is the provided scope? The provided scope means you do not need these jars to be deployed with the application. These jars are already provided into the deployment environment. Most commonly, the jars for Servlet API, JSP API, which are typically required for the web application execution. So you realize that these jars, you need it as a part of compilation during your project. However, you need not to deploy them separately, because any Java web server, they have built-in implementation of these jars. Apart from compile and provided there is another one, let's say test scope. Now test scopes are all those libraries, those jars which you need only during execution of the unit test cases of your project. A most common example would be the JUnit jar. The JUnit jar, you do not need it for the final execution, but you need it only during execution of the unit test cases. Apart from that, there is one more scope, we call it as a system scope. The system scope is quite similar to the provided scope, but in provided scope, we are saying that the jars are will be available at runtime, but you need them during compilation, and hence they are downloaded from the some central repository. However, the system jars, they are not downloaded from the system repository, rather they are taken from your current development system, where you can specify the additional system path for that. Apart from these paths, there is one more scope called as import scope, which is applicable only for the POM kind of stuff. And finally, the last scope, you call it as a runtime scope. The runtime scope is something which you say that you need the jar for execution of the program. So while executing, you want them into the class path. However, you do not need them during compilation. The best example will be your JDBC jar. Like MySQL connector jar, you need it only during the execution, because while compilation of JDBC program, it is always compiled against JDBC interfaces which are part of your Java runtime itself. Now, as you have understood these dependencies, which is most important part that you must be knowing, there are few more things that you can explore. There is also a concept of build profiles. The build profile is set of configuration, set of settings which are applicable for certain environment, like development environment, like production environment, and so on. We can use Maven profile concept over there. Apart from that, there is also Maven repositories. As I told you already, by default, Maven downloads from central repository. But if you want to download from your organizational internal repository, you must be specifying the path of these remote repositories over here. The Maven does all its compilation and building through something called as a Maven build plugins. We will talk a little more into some other slide. But if you want to put all these Maven configuration, Maven settings into this pom.xml file, writing same pom.xml for different applications or similar application can be a repetitive task. If you want that your application build settings should be similar for other projects too, better you consider making it parent POM. In companies, we also developed something called as a multi-module projects, where your one big application is divided into the small modules, but you want to keep the build settings of all of them as similar way. This is another place where most commonly the parent POM concept is used. The parent POM concept is a place where you can put in all common build settings, and then every new project that you are creating, you can just specify the parent section, and all settings which are given in the parent POM will be inherited in your project. If you want, you can override certain settings. Yes, This concept is quite similar to object-oriented inheritance principle. Now, this technique is commonly used by the modern frameworks like Spring Boot. Every Spring Boot project, whatever pom.xml we create, that pom.xml already have some Spring Boot starter parent declared on the top. Now this starter parent indirectly specifies the build plugins, specifies the versions of dependencies that are to be used, which makes your life quite simple when you are writing your own project pom.xml file. This pom.xml concept, I guess you have got enough idea about it. So now it's time to move further and talk about how exactly Java application is built by the Maven. So there is a concept called the Maven build lifecycle. There are three build lifecycle. One is the default lifecycle, which is main lifecycle of the Maven, and that builds your Java application. There is a second one called the clean, which delete all auto-generated files during compilation process like .class files, some XML files along with properties file, or for that sake some of the packages and all that. So those get deleted. And third one is a site which build the project site documentation for you. Now each this life cycle is made up of multiple build phases. Most important life cycle is default life cycle. So let us take a look at the most important build life cycle phases over there. The first life cycle phase in a default is a validate phase, which ensure that everything that you need for building the application is available, which also includes the third party libraries. If libraries are not present on local repository, those will get downloaded from central or remote repository into the local repository. Then the next phase is compile phase, where the source code is compiled. If required, those project libraries will be added into the project class path, especially when the scope is compiled. After that, there is one more phase which I haven't put in a slide called a test compile phase, which is actually compiling the unit test source code of your project. Followed by that, there is a package phase. The package phase where the actual artifact, the actual jar or war file is created depending on settings given in pom.xml file. Once this package is ready, you might want this package to be accessed on another application on the same machine. For that, you need to install your current package into your local repository, and that is done by using the install phase. Finally, if the created jar or war you want to share with your colleagues who are working on some other project, you can deploy this jar war into remote repository of your organization, and that is done using this deploy phase. Now you can try to give multiple build lifecycle together. You can mention something on command line like mvn command and clean install. If I write clean install, first the clean lifecycle is executed, which will delete all generated files, and it will execute the default lifecycle. Please note we have given install over there, which is nothing but almost 6/7 phase of your lifecycle. Keep in mind, whenever you are giving any phase, it will execute right from the first phase up to that phase. So when I mention Maven install, it is taking care of executing validate, compile, compile, test, package, and then install. All these phases will get executed. By the way, what do you mean by phases get executed? Your each phase is again a sequence of goals, and that every goal that is been given is a small task bound to some phase. A simple example would be a compile goal. The compile goal is bound to compile phase, which is compiling the source code, or for that sake, surefire test is bound to the test phase, or we have like a jar or war goals which are for the packaging phase, and so on. Now, as you see, these are the build goals, which are the smallest tasks which are done during Maven application build. These goals are implemented into something called as Maven plugin. The Maven plugin implement one or more goals, one or more actions, and most importantly, not all goals need to be from the same phase. One Maven build plugin may have multiple goals from different build phases. For example, the compile and test compile goals from the Maven compiler plugin, they are applicable for the compile and test compile phases, right? Not only that, even third-party plugins are implemented by the framework to provide the custom goals. A good example would be Spring Boot plugin goals. Now, Spring Boot has got its own its own plugin, and that plugin provides you certain goals like help or run or let's say repackage the application. What you need to do is you need to put these plugin information under build section in your pom.xml file. Now, as you have understood the Maven build lifecycle, now you want to ask the question, how do I install Maven? Okay, to install Maven, you need to first download the Maven from Apache website. You can just unzip it and you can start using it. If you are on Linux systems like Ubuntu, Maven is also part of their package manager. On Ubuntu, we simply give a command apt install Maven and the Maven get downloaded and installed on your system. And once Maven is downloaded, it is purely a command line tool. You can give the command mvn and then you can provide some phase in the default lifecycle like mvn test, mvn package, or what I shown you earlier was like Maven mvn clean install. That is most common that we see it. Now, this approach, even though you can use it, as we are doing all our development in integrated development environments, good thing is that all modern IDEs have built-in support for the Maven. So IDEs like Eclipse, IntelliJ IDE, and even others, they have very good support for the Maven. So practically speaking, you need not to install all these Maven onto your machine manually, at least for the basic development purposes. Now it's time. I would like to take you to the Eclipse IDE and we will create a simple Maven project and try to see the practical aspect of the Maven. Here I'm using Eclipse STS IDE. You can use any Eclipse version that you are comfortable. I will go to the Maven, new, and select the project. I want to use Maven project. Let us click on next. You can create a simple project. Simple project meaning by I want to create a project from scratch. If you do not check mark this, you need to make some archetype selection. The archetype selection is like a default project template. I do not want to use any default project template. I just want to create from scratch. So I'm creating a simple project. I need to specify group ID. Group ID is package name that represent your organization, your team who is developing this application. Then we have artifact ID, that is identity of your project, that is identity of generated jar or war file, whatever that you want to give. So let's say I'm giving a name, let's say Maven demo. The same one I want to use it as my Eclipse project name. Please note that I'm keeping the packaging is equal to jar. Jar packaging is for a simple Java application, and we can use war for the web application. There is also a version to be given. Whenever the snapshot word is added into the version, it only means that this is under active development. I can click on finish and the Maven project will get ready. You will see that in every Maven project, we have certain directories created. We have something src main Java directory created in which you are expected to write the source code of your application. Like I want to write, let's say a main class. Main class, I'm giving a name, let's say example main. All right. Now, the next thing, we also have a resources directory. This is a place where you want to put some configuration settings like XML settings or like properties file or some other configuration or some images or fonts. If you want to add it, the resources could be a good place. As far as writing unit test cases is concerned, that should be written under src test Java, and resources required during testing has to be put in src test resources. If you have noted it, by default it is using Java version 1.5. Why? Because by default all your Maven projects they have Java version 1.5. What if I want to use Java 1.8 or Java 11? You can go into your project's pom.xml file, and into the pom.xml file you can specify the version that you are looking for. Please make a note that the pom.xml file is always in the root of your application folder. Now inside this, let me mention some properties, and the properties what I have is maven dot compiler dot source property. I'm going to use Java 11 and something similar, not the source but target. Target again I'm giving it 11, where I want to say that I'm going to compile using Java compiler 11 and dot class file is ready to run on JVM of Java 11. If you want to use that 1.8 version, don't write 8, write 1.8 over here. Now you see that this setting is not yet applied. Whenever you are changing some basic build settings or you are adding some build plugins into pom.xml, it is recommended to update the Maven project, and that is done by right click on your project Maven and you can say update project. Now when you say update project, you can see that these settings are applied over here, and now the version is Java 11. Now what exactly I want to do in this project? Definitely I could give you a demo of a JDBC or like a web application or something, but just to keep it very simple and to give you the clear idea, I thought of using some special library which converts the Java objects into JSON and reverse. Well, there are couple of such libraries are there like JSON, Jackson, and so on. My personal favorite is Jackson library. So I want to add the dependency of the Jackson library over here. But the question is from where I'll get that. You can go into Maven central repository for that. So let me open a browser, and all you need to tell browser is I want Jackson databind Maven. Good. And you can jump into this. Please note that this is mvnrepository.com, which is nothing but the central repository. And now I want to use the latest version of this Jackson databind. Great. Do you see that? Oh, it is having something. And if I just click into this, you see that even it is copied into the clipboard, which just tells you that, okay, this is to be copied and has to be put in a pom.xml in dependency section. I just want to show you one more thing before we paste it over there. You find that this Jackson databind library is internally dependent on two more libraries like Jackson annotation and Jackson core libraries. Okay, that is great. So let me paste it over here. Let me indent it and let me save it. Now, moment you start saving it, you should find that in a progress bar, it will take care of downloading that library plus even other libraries. Like, let me show you these Maven libraries, all three jars, they are added in my project class path. Now, how to use it? Yes, Jackson learning itself is a huge thing, but let us make a very simple class and let us have a quick test. I'm creating a simple class called a person, and into the person class, you can declare some members. Let's say I want to give some name, or you might want to give some address, or you want to give it something, let's say pin code or whatever, choice is yours. You can make some constructor, you can make some parameter constructor, you can use, let's say, getter setters. If you want, you can also create a toString method and so on and so forth. So the basic simple Pojo class, here I'm creating it. Of course, I don't want to use the class directly. I want to show you how to convert it into the JSON using this Jackson library. Let us go ahead. Let me create the person object. So person p1 is equal to new person, and you want to give some name, you want to give some address, you want to give something pin code. Okay, that is done. To use this Jackson library, they have one special object called as object mapper. This object mapper, let's create its object, and there are several methods in this little mapper. Several methods in this mapper. If you are interested in, definitely you can Google search and try to learn more about Jackson. To give a simple demo, I just want to convert it into the JSON string. So there is a method called as a write value as string. Okay, I'm passing the p1 object, and what it returns me is string, JSON string, which I can print on console. Right, done. Obviously, this method throws IO exception, a checked exception. So I will just try to put a try catch block for this. If at all any exception is there, which I want to print it over here. Done. Let me run my application and check if it is able to convert it into the JSON format. Wow. So my Java object is converted into the JSON below. I hope you see how simple it is to add third-party jars and their dependencies into your project and start using. I hope you found this video very much useful. Thank you very much for watching this. Stay tuned. See you soon again. Thank you.